knot, right? Like that, and you go, whoop, right? But if I just connect any two knots willy-nilly, then I get lots of stuff, you would assume. So that's why this operation is like very precisely defined, but perhaps it's not so precisely defined because someone else might have said, maybe I can find, a different way of using this rectangle. So someone else might say, let's see, what else can we do here? So let's take the two things again. Somehow I'm not as good as drawing this one. Okay, someone else might say, instead of using a rectangle like this, let's do something like okay. So here's the rectangle thingy. So remember, this kind of topology, everything's rubbery. Right? Nothing's rigid in this world. So someone might do something like that and say they're going to replace these two arcs by these long things. All right. So the question is, I originally connected to here. Now we're connecting down to this other piece. Is that going to give me the same thing? Right. So here's K. Say here's J. I guess the question is, does are there different K sum J's? Okay, so that's a question. Given two knots K and J, is what I described enough to give me always the same knot? Or it can look different, the result can look different, but maybe I can do ambient isotopy and get to always the same thing. And the kind of maybe surprising fact, it's surprising because it's almost, you would think you either get a bunch of different things and it's like a bad operation in that sense, or you might think I always get the same thing and it's like magic. But the answer is, you can get at most 2 knots from the knot sum of K and J. So at 2, maybe I should, I think when you say 2 knots you understand they're different, but let's just emphasize the 2 different knots. At most two different knots. Right, so in some cases you might find out, you always, it doesn't, depending on what K and J you started with, you always get the same thing. But in some cases, depending on K and J, you might get this operation sort of ambiguous enough, you can get 2 different guys. Okay? It's kind of, for actually in this particular case of the truffle and the figure 8, it doesn't matter like how I do it, as long as I follow this scheme with the rectangle. Place the 2 knots sort of far enough and then connect them with this rectangle, switch the sides. Doesn't matter how I pick the rectangle, I'll always get the same one in this particular example of these 2 knots that I gave you. So it's a little surprising maybe. Think about it, there should be some sense to it. But the book kind of goes a little bit further into this. I think maybe we'll be back. It's a little bit too much, I think, to think about in one sitting. And there's not really any exercise in the book or a good exercise I could think of that aren't too complicated. I think most of the problems most of the problems about what you can get and stuff are a little involved, so I think we'll skip those for now. Alright, so any questions? So this is 1.2. You should take a look at the rest of 1.2. There's still some stuff about things like invertible or reversible knots and stuff like that. so now that we've talked about knot sum, we can talk about composite and prime knots. I guess one thing I should mention is the connected sum of two knots doesn't depend on what order. Like I guess when you see an operation like this, you see K's on the left and J's on the right, right? You might, and what it means is you took this and put it on the left, and you put this on the right, and you did this thing. But I guess the question is, what if you flip the order? So I guess another way of thinking about it is, let's look at the trefoil example here. So you have one knot like this, and you have to figure 8. Why am I having trouble with this?
Doesn't it depend on the direction also?
The direction?
Direction that you're going.
Well, I think it doesn't. I'm not sure I understand your question, but
Like the direction is the strand, I guess, goes from K to J.
oh, you mean this orange thing?
Yeah, the direction.
Well, my claim is you only get at most 2 different things by doing anything possible with this orange thing. So some things depend. So the result is the result of whether you have 1 or 2 different results of this non-sum isn't so much about the rectangle thingy. It actually kind of depends on K and J, properties of K and J. Anyway, say you have this, and then I sum. Let's take the. Since it didn't, I told you beforehand it didn't matter which way to do it with these knots. Let's just do it that way. And I guess you could say, well, let's start with the figure 8 knot on one side. Same diagram with the figure 8 knot. Put the trefoil on the other side. Do this. Right? Are these the same? Did it matter? I mean, it seems kind of dumb when you first hear the question, because it's like, why would it matter? But sometimes it matters which way you do stuff, right? Which order. So are these the same?
No, because it's connected to a different strand of the trefoil.
Well, no, because it's connected to the same strand of the trefoil.
Different.
Or different. Okay, so that's an interesting thought. Who else who has another comment? Who thinks no also? Or who thinks yes?
What?
The questions, are these the same knot? Or are they different? Jillian?
They're different.
Yeah.
The direction. Like in the book, it says all the knots have like a direction that they're going.
Oh, right. You read this section.
I think the directions are different.
Okay.
Maybe.
All right. So Jillian's read a bit about orientation. Jesse?
I think they're the same because if you add them, you're still getting the same thing.
Okay, because it's because we call it not sum or a connected sum.
Yeah.
Sums are used to being so it doesn't matter what word. I guess the language, that's kind of a different kind of reason. It's not mathematical language so much as, or reasoning so much as reasoning about mathematicians. Right, so with mathematicians call it not sum, it doesn't matter which order. Okay, so let me put it this way. In the case when you have 2 knots where you have a well-defined or a unique result for the knot sum. So suppose you got a unique, there's only one possibility for this. You're not in the weird case where you have 2 things. This actually ends up being the same as the other one. There's a very easy argument to see that. Okay, so maybe let's draw this in a little bit more of an instructive fashion here.